Alright guys, welcome to the channel. Today I have the Cambridge Soundworks OontZ Angle 3 Bluetooth portable speaker off of Amazon. And at the time of this recording, it is one of the most popular portable Bluetooth speakers on Amazon with 108,000 reviews and an overall rating of 4.6 stars. Now, Cambridge, that might sound familiar to some people. That's a university or a town in Massachusetts. And so I looked into the history of this company, and it was started in 1988 by an audio engineer who no doubt graduated from one of the prestigious schools in and near Cambridge. And so this might be a really high quality. The price that I paid for it was $25.99. And so American made, American designed, well, I don't know if it's American made, American designed, American company that was started by an audio engineer for $25.99. That sounds like a pretty good deal. And with 108,000 reviews and a 4.6 star rating, that sounds even better. So what I'm going to be doing today, this isn't exactly your grandma's unboxing, so to speak. I am a product design engineer, so I like to tear things down and analyze them from that perspective. Now, I'm also a bit of an audiophile, so I do know what good speakers sound like. So I will, just because I am into products like this, I will be giving you my impression of how the speakers sound at the end. But really, the main point of this is I'm going to analyze this from my professional perspective, which might not be for everybody. A lot of people are going to be like, you know what, I just want to know if it's a good value for the money and what features it has and how easy it is to pair to your phone and stuff like that. And so if that's the information you're looking for, then this is not the review for you. But if you're interested in nerding out on all the internals of this product and seeing how quality the parts are made and how quality the overall design is, then this is exactly the review for you. So if that sounds fun, then I hope you stick around. All right, guys, well, let's get into the actual design review and take a look at this from a technical perspective. So first off, it is made in China, just like everything else. iPhones, Dell laptops, made in China, designed in America, made in China, or at least the company is an American company. So there's the tech specs. So this right here is injection molded plastic. Those are cool. Instead of making them circles, they went to the effort of making them triangular. That's a little extra design effort. Most of the time you put holes in this many holes in something, you'd make them circular. So that shows a little bit more effort on the design side. And this is a separate piece of plastic right here, probably also injection molded. The finish is good. It's not exactly as quality as I would expect from, it's not the highest end. You can tell that the plastic finish is not the highest end. Now, where there is really high end is these end caps. These end caps, man, I wish you could feel them. They feel like velvety butter, which is very expensive to do. In rubber manufacturing, basically the better the feel to the skin, the more expensive both the process and the material is. So not only do you have to have your processing right, this is probably either, it might be a thermoplastic elastomer, which just means that it's a meltable rubber that can be molded inside the same machines that make hard plastic. That's all that TPE is. This is pushing the boundaries of what TPE can do in my experience. So this could be a different manufacturing process called liquid silicon rubber injection process, or LSR, and it is 2 to 3 to 10 times more expensive per part, both because the process is slower and because the materials are more expensive, and the equipment used to make LSR silicone rubber is just a more expensive equipment, and a more rare equipment. So it's more expensive on multiple reasons, but it is just gorgeous to touch, and it's on both ends. So that is really, they went the extra effort to give this a quality high-end feel. You can see that there's light shining through there, so this might have to be a bi-injection molded part, or a part that is molded with a secondary process, or it could just be they made the rubber so thin right there and they made that LED really bright that it just shines through anyway. It does look like it's a little, the light is muffled a little bit. So we'll see when we get in there exactly what's going on there. But yeah, from the outside, this is perforated metal, sheet metal with that's been formed to this shape with like a die, and then laser cut holes, very precise laser cut holes in it. So that's that pretty much sums up the outside. So let's start taking it apart and see what else we can figure out. Yeah, so this is not this is a separate piece. It's not molded over. Some products have the rubber actually molded over the rubber, or the hard plastic parts in a bi-injection process, but that's not what this is. These are just separate parts that are stretch fit over and fit inside those grooves right there. Yeah, that right there fits inside those grooves. So that's a good design. Again, very, very nice feel. So you can see the difference in finish. They put a special finish on the outside of the mold, on the what they call the cavity side that makes this part, and then on the core side, because that side isn't seen, they didn't bother putting a special finish on that, because it definitely takes a very, very highly engineered specific finish to get this velvety, smooth, silky texture. So, all right, let's do the other. So this is where the user interface ends. So there almost has to be a PCB, a printed circuit board, underneath here. And there is. Okay, so this one is yeah. So you wouldn't expect a lot of design effort went into just making buttons, but it actually does. See these circles? So if it wasn't for those rubber bosses, basically every time you'd push down, the button wouldn't want to rebound back, and a lot of trial and error goes into getting those right. And you can see they put ribs everywhere to support it, because it's kind of hollow. It's being supported by the 3 buttons, but everywhere in between, it doesn't have anything pushing up. So if it didn't have that, then you might see, a little depression like that, and that wouldn't look very quality if you saw a warp in this part, like that. So a lot of design effort goes into making this user interface work well. It got standoffs there in the corner to make it sit at the right height, and yeah, so probably the highest quality mechanical part on here that we're going to find is those right there. All right, so this circuit board is, I'm betting that's the antenna right there. So if you don't know a lot about circuit boards, basically if there's anything electrical, it has a printed circuit board. It's basically the workhorse of the modern world. This is basically an entire computer right here, just like what fits in your phone, except this probably doesn't have anywhere near the computing power, but it's got everything built in. Every single thing that needed to control this unit is right here, and if I'm not positive, but I'm guessing that that is the Bluetooth antenna. So you don't even need to have an antenna sticking up off of the board. You can build it into the metal traces. And again, PCBs have alternating layers of metal, copper, metal, or metal, plastic, polymer, metal, plastic, polymer, metal, plastic, polymer, metal, so that there can be all different kinds of different connection layers going on inside the board, and you can kind of see them. That right here, there's just plastic, and circuit boards are made out of a thermoset plastic. I can't recall the name at the moment, but it's so that's what the green is the actual plastic. And then you can see where the metal traces stop and end. And of course, if that's an antenna, you don't want to have metal traces around it interfering with the antenna. So that looks like a good design. But again, that's outside of my expertise. I'm not a circuit board designer, electrical engineer, but I have worked closely enough with electrical engineers. Basically every product I've designed has needed one of these, so I know my way around it, know what to look for, and what the general processes on how they're made and stuff like that. So one thing, I wanted to see if so that is a pretty bright LED, and then it's not a special clear plastic that's right there where it comes through. They just made it really thin, so nothing. And then in the thin part, so they made that like a super thin membrane that doesn't block out the light. So that's really efficient engineering right there. You know what, now that I look at it, it actually, I don't know if that's I think they just made it thin instead of putting. You can make much more complex user interfaces that actually have multiple steps of different color rubbers injected onto the same part, and so some can be clear, some can be you can make the buttons different colors than the rest of the body of the part, but that is expensive. Again, multiplying your expenses on, if this is a liquid silicone part, that's already expensive, and so every time you multiply that process, it's like having to make another one of these parts from a expense perspective. So that's good efficient engineering to just make it so thin right back there that the LED comes through. So that's pretty smart. All right, so it looks like we can start with these right here. Okay, so this is really interesting. So it has a amplifier, mechanical speaker amplifier built into the bottom cover. So that's probably one reason why it doesn't distort so bad. I've never seen or heard of anything like that. But again, I'm not an audio engineer, just a general product design engineer. So, but that's really cool. So no electrical going to it whatsoever. So it's simply a mechanical device. But so let's take that off, see what it looks like. Okay, so all right, so there's metal. That center piece is metal. It looks like it's, so this is probably a thermoplastic elastomer, some kind, and it has actually had the metal piece has been put in the mold, and then the rubber has been shot around the rubber to make it bond. Either that, or it's been bonded with an adhesive, which could be either one. But a over molded design would definitely be more efficient from a cost perspective. So you can kind of see where the two pieces come together right there, and I can kind of pull them apart. So that's really cool. Not so standard manufacturing process right there. Just a general injection molded part right here. You can see the ejector pins right there. Those circles. Yeah, not a whole lot to that. Probably ABS, polycarbonate ABS maybe. Same with this part. You can kind of see on the back here. So these are date and or batch stamps. So yeah, it looks like this is a date, a year and month. So this was shot in July of 2020, looks like. And this is cavity 2. So this is at least a 2 cavity mold where one is right next to the other, and it shoots 2 at a time to save time. So looking pretty good quality so far. Yeah, so let's see if I can get this off. So it looks like that has been permanently crimped onto there, which makes sense that you wouldn't want that piece to just be a slip fit, because it would rattle. This right here is the battery, and let's get that apart and see if we can see how big of a battery it is. Just for another simple injection molded part. Probably cost pennies, even stateside. Alright, so to be able to tell anything, I gotta take this nice sound deadening tape off of it. And it looks like it's glued, or it's sticky tape. So oh yeah, and it doesn't, the whole thing is wrapped in shrink wrap plastic, so I'm not going to be able to tell anything without basically breaking it. So I'm just going to leave that just like it is and moving on. So all right, well, let's take the circuit board off and see what we got there. Okay, so that's the microphone built in right there, so you can voice control your phone and your player. Oh, okay, so these electrical connections are preventing it from coming out. Okay, it looks like that microphone has been glued in there, which makes sense that you wouldn't want it to rattle around. So, and then these wires are soldered to the board, so I can't really take this apart without ruining it. And I would like to keep it working, but really the only thing you're missing is, what's the underside of the board. So this is components are populated. All the nerdy electrical components are populated on this side of the board, and then really this is what they call the UI side of the board that has the buttons for the user to interact with, and LED lights and stuff like that. Very common board layout. Yeah. So. Yeah, pretty standard. Oh, let's see. I am curious about the material. And it looks like, I don't know if you can see up in there, but it says a lot of times quality products will have the material printed in or molded into the mold, and that's kind of one of my areas of specialty is polymers, and so it's always interesting to me to see what materials other engineers have chosen. So it looks like this says BC 202 3A, and then it has date, year, and month stamps in there also. So yeah, BC 2002 3A. So let me Google that real quick and see if that tells us anything. Okay, so the closest thing I was able to find was something referring to a weatherproofing standard, but even that didn't make sense. It doesn't make sense that it would be a part number either, because none of the other parts have part numbers on them. So I'm at a loss. I don't know what that is. It's really disappointing that they don't call out the material, at least to me, because that would have been really cool just from my perspective. Yeah, so there are the speakers. Good soldered connections. They're screwed into from this side. If I could get this off without breaking it, I would, but I don't think I'm going to be able to, because that's been formed onto there. So this is a pretty cool injection molded part. A lot of detail went into the design to make the triangular shape. So cavity and core made this, and then looks like it also might have some slides. I'm not sure. Yeah, it definitely has to have slides to make those bosses for the screw holes. So there is a slide that comes in here and makes those shapes, and there's also a slide that comes in here and makes these shapes. So main half of the mold, side A, hang on. Yeah, well, it depends. It can be either or, but anyway, main half, two halves of the mold, and then slide. So, and I'm kind of surprised I can't find an injection location. Now it could be well hidden underneath this shroud right here, this screen, which would be the ideal place to put it, so that it can't be. But really, there's very little plastic exposed. The only piece that has plastic exposed is this one, and on this one they also did a really good job of hiding the gate location. It looks like, yeah, it's gotta be an edge gate, because yeah, I can't find one anywhere. So yeah, this is a well-made product. To go to the effort of hiding your injection location means that the mold, this is probably shot stateside, and I mean there are good injection molders in China, but you have to look long and hard to find them. So but this is a really high quality tool. It adds a lot of expense to an injection mold to add fancy gating. Yeah, I can't find the gate, so that's a high quality piece, and probably same with these. I can't find where they're injected, so they went to great effort to make these high quality plastic pieces. All right, well, I think that covers it, guys. That's about all I can tell from the outside without using it for multiple years. So hope you enjoyed this type of teardown slash unboxing slash product review. If you liked it, give me a thumbs up down below. If you really liked it, give me a subscribe. Leave a comment if you had any questions that I didn't cover, or any questions about other technical topics that I covered in this video. Feel free to slam them down below. If you didn't like it for some reason, you didn't like the content, leave me a comment. Let me know why. But until next time, guys, hope you enjoyed it. Have a nice day.